I apologize for my crimes against all things musical. This was my installation at EMF 2022. I'd already built one robot slide whistle ages ago, so I figured it would be easy to build 3 more and put them in a box. And maybe it would have been if everything had gone to plan. I started building this barely 2 weeks before the event, and it's a miracle I got anything working at all. It had been years since I built the first one, and in that time almost every component had been a victim of shrinkflation. I bought 4 of what I thought was the same fan motor, only to find that they were like miniature versions, 40 watt instead of 55 watt. I bought several from different suppliers, and none of them were any good. All of them were smaller and noisier. Very irritating. Even the slide whistles had been shrunk. I imagine that on a production run of 1 billion slide whistles, shaving off a tiny bit of plastic saves a huge amount of money, but for me, the slide whistles being a slightly different size means I can't reuse the design files, and everything takes longer. Mercifully, I was able to get hold of the servo motors. Although there is a newer version available, there was still old stock of the AX12A. I could have solved my air pump problems by building bellows, and given enough time I would have, but remember that each whistle needs a separately regulated flow of air. The pitch depends on the flow rate, so that would mean either 4 sets of bellows or some kind of regulating apparatus that I didn't feel comfortable experimenting with in the time remaining. The plywood enclosure is custom built, though I didn't get a chance to finish the exterior. In the back here we've got the fan motors, the control board and power supply. The grey fur is my attempt at soundproofing, which is surprisingly effective. This bicycle inner tube and elastic does a very good job of decoupling fan noise from the wooden box. The circuit board is an STM32F401 black pill surrounded by some increasingly desperate transistor arrangements. See, the way I wired up the very first slide whistle generated quite a lot of heat, so I figured this time I'd do it properly and use MOSFETs. But I made a small mistake with the level shifting. That means that when the processor is in reset, the motors all go to full power. I added a hard cutout switch to the motor power, but if you forget to hit that switch before reprogramming the chip, you're faced with unbelievably loud screams as all the whistles jump up several octaves, like, we're programming, ah! After the 3rd time this happened, I added a whole load more transistors to reverse the logic level and stop it for good. The googly eyes were a later addition. The original slide whistle did not need feedback. You'd do a single calibration and it would then be reasonably in tune. These slide whistles are not in tune. Even if I do a full calibration on each whistle individually, it's not even close to being in tune. The problem that I eventually discovered is that these fan motors are unpredictable. I think it's the grease warms up if they've been on for a while, and merely setting the power level is not enough to get a consistent flow rate. I managed to partly alleviate this problem by drilling holes in the pumps to create an intentional leak, which means we can run the motors a bit closer to full power. The theory being, if we can run them at a higher power level, then the effects of friction will be less significant. Although this helped a little bit, the results are far from adequate. It's not like I haven't considered adding feedback. I played a bit with adding contact mics onto each whistle, but I concluded that it would be very hard to isolate the pitch of just one whistle when all four are playing. Instead, what I'd like to do next is fit encoders to each of the fan motors and control them with a PID loop. If we can get predictable airflow, I think most of our problems will go away. At the event, nobody seemed to care that it was out of tune. If anything, that just made it funnier. People really enjoyed the real-time playability. I added a polyphonic algorithm that chooses the nearest whistle as you play each note. That, at least, is one bit of the project that worked really well. I saw the comment requesting Beethoven's Ninth Symphony on slide whistles, and I concur that it would be magnificent. The problem is, arranging music for robot slide whistles isn't easy. The range is just 1.5 octaves, and the portamento is mandatory. But we can partially solve our problems using software. A few years ago I made a robot slide whistle emulator, and using this we can get a very basic idea of what MIDI files will sound like when sent to the machine. It runs in a web browser, of course, using WebMIDI, and if you'd like to have a go with it, you can head to this address. I don't expect anyone to do all of Beethoven's Ninth, but if you do come up with something nice, then feel free to send it to me, and maybe I can record it playing on the real thing. As always, there's more information on mitzeller.com, and if you enjoy this nonsense and you want to send me money, consider joining the Patreon.